Awesome. We are live. Hey, everyone. I'm Jen, and welcome to Blockchain Banter. Thank you so much for joining me. We've got a special back to back today. I'm here with Angela, founder of Token Engineering Academy, and Dr. Mark Richardson of Bancor and Carbon DeFi. Last, we kind of went into a DeFi education series, and Angela introduced Token Engineering Academy, what their study season is. We've got some live track info from Mark, something that he's going to be leading. But before we jump into that, Angela, for anybody who might have missed our previous call or be unfamiliar with Token Engineering Academy and the study season that you guys are kicking off, maybe you can just give us a little bit of background, similar to kind of what we did last time. Anything that you want anybody to know about Token Engineering Academy and about the study season.
Cool. First of all, thanks for having us again, Jen and Mark. It's a pleasure to be here. And let me tell you a little bit about Token Engineering Academy. We are running the study season. This is a cohort-based program with students of token engineering from April. So we are starting just in a couple of days until July 2024. We have an amazing program, a combination of online courses and live tracks. And first of all, maybe some words about what token engineering is. This is a combination of disciplines that we are establishing as a new engineering discipline in its own right. We all know that we can create tokens with a couple of lines of code, but when it comes to the mechanism design and when it comes to optimizing verification of the mechanisms we design, then we have to do more, and we can draw actually from a range of existing disciplines, such as computer science, cryptography. I guess we get to that in this conversation today. Economics and game theory. We can draw from systems engineering, because with token systems, we are actually designing systems, dynamical systems, complex systems, in fact. We can draw from operations research and management science. We can apply AI, control theory, data science to monitor these systems, also to make them autonomous to some degree, balancing interactions, for example. And we are talking about socio-technical systems. We have humans in the loop. And that's why we need psychology, decision science, behavioral economics, political science and governance when it comes to token-based governance in DAOs, and philosophy, law, and ethics. And this is, in fact, a combination of disciplines that you can't study at no university today. And TE Academy was started in 2020 because of this need, because we don't have anything similar on any traditional university. And in fact, it is a crypto-native new discipline. So we started Token Engineering Academy. And since then, more than 4,000 students are enrolled in our programs. We have a good mix of people with an economics, computer science, engineering, data science, math background, and more than 1,000 exams were already passed. We've launched a bachelor level course in token engineering covering the full token engineering design process, from the requirements engineering to mechanism design to the verification of this design using modeling and simulations, to token-based governance for token engineers, 5 modules. This is an online course. It's available at tokenengineering.net. You can enroll anytime, study at your own pace. And again, more than 1,000 exams have been passed already by 4,000 students. That's pretty amazing. Now, our next step is the study season. Again, this is a cohort-based program. So we'll meet over around 12 weeks with students. You can also register at tokenengineering.net and meet other students, meet really great live track speakers, come to EFCC and make connections and learn how token engineering works, from the fundamentals to first-hand experience from founders, from crypto economic researchers and practitioners in the field. And I think this is an awesome opportunity for anyone who's interested in this field, in this growing field, in fact. And the motto is share, learn, grow. Key dates, we'll kick it off this week. You can register still. We'll then have weekly study sessions. Expect 3 to 7 study sessions per week in different tracks. So any student can find most interesting and combine the live tracks as it fits best to personal learning goals. And in parallel, you can study, if you haven't, TE Fundamentals, the bachelor level program. And we offer proof of knowledge at the end of the study season for the students who passed a certain knowledge criteria. Then, June 10th is start of the exams week. And July 9th and 10th will be at IFCC in Brussels. We'll have the winners of the first fellowship program. I'll get to this in a moment. We'll have a dedicated token engineering track at IFCC with token engineering talks. Really an amazing agenda of the day. So it'll be super exciting for anyone interested in this field, and also a big community meeting. And July 25th, we are concluding the program. I talked about learning for a bit. Let's get to the live tracks. We'll have 4 different learning sessions or combinations of learning sessions. Number 1 is German Forschengier. She'll give 4 live sessions about token design thinking. So she'll introduce her framework and will go over a case study with the students to better understand the initial design of a token network. And this is super relevant and a great onboarding course for any crypto founder, protocol designers, token engineers. Trent McConaughey from Ocean Protocol will join us talking about their big token merge. You might have heard it, the AI Alliance. This is just a big step for Ocean Protocol, and I think it's super exciting to hear more from a founder how to manage such a token merge. Then the third track that we'll discuss in a moment will be actually Mark. So we'll collaborate here, and we are super happy to have this track, Algorithm Design DeFi Concentrated Liquidity from Scratch. And track 4 will be the A to Z case study reputation-based weighted voting, where we'll start with requirements for a new token mechanism and then go all the way down to shaping the voting design, verifying the voting design, running simulations, understanding weaknesses, optimize the parameter setting, go to implementation, and see the results. Because based on this voting mechanism, we'll distribute the first or vote on the first Token Engineering Academy Fellowship grant with 10K for 4 candidates that we'll announce this week. So every community member is invited to vote based on this voting mechanisms that we'll design together in the study season. So a super exciting program. And you can all join and register still at tokenengineering.net. And now I'd love to take a look at Mark's program, DeFi's Concentrated Liquidity from Scratch. Mark, when you came up with this idea to run this course, I was immediately excited about it because I think it's one of the rare chances to explore a certain primitive in detail and gain a proper understanding for it, no matter if you're a token designer, want to implement concentrated liquidity, or even as an investor. And I think we are still lacking this knowledge. And this, I guess, was also part of your motivation to create this course.
Yes, absolutely. So it's been I think it's been a long time coming. I've done versions of this slightly more focused, or let's say less general, with things like the bonding curve research group, for example, where we kind of address the mathematical motivations behind, certain descriptions of bonding curves and what do they mean and that sort of thing. But I think that there's a lot of confusion that's resulted from what I call the conflation of marketing and research efforts in the DeFi space. And what it's resulted in is, I think, what Angela will know to be a dangerous half-truth, I think, is the German idiom that I've always had a deep appreciation for. But yeah, essentially a dangerous half knowledge, I think, is the more accurate word. But yeah, I was looking around. Yeah, exactly. I was looking around at the sort of collection of white papers, and some of them you can't even find anymore, which is very upsetting, because there were some really terrific white papers out there, like the original Dodo white paper, which is one of the few unique bonding curve implementations. And while the description in the white paper was maybe a little brief, it still was quite dense with new and interesting ideas. And it's a shame now that people that are showing up to the space for the first time are kind of now deprived of being exposed to it. And I also think that the time that you're exposed to it and the current status of the industry when these white papers are released, the context there is also important, because there's a natural flow from one idea into the next. And if you're arriving in cryptocurrency and in DeFi and in token engineering for the first time in 2024, I feel bad for you that you haven't had that opportunity to see these things evolve from first principles. And I want to do something about it. And I want to do something about it in a way that's like rigorous, in a way that's not hand wavy, where we don't do the marketing thing by making things simple or easy, but in a way letting things be hard, and having a respect for the would-be token engineering scholars, and giving them an accurate feeling for for what it means to be an active participant in this discipline. And so the course is, I think for some people, it will feel like, like we're really doing this, like this isn't, we're not going to deal just with, heuristics. We're not going to have, we're not going to make things simple or easy. It's going to be an as-is course. And this means that, there will be concepts in calculus, in differential geometry, in linear algebra, and so on. And you shouldn't be terrified of any of these things, because they're all learnable. And it's important to realize that, when I came into the space, I hadn't had, a formal education in mathematics. I did exclusively organic chemistry. And so while I was exposed to a little bit of these kinds of things, I certainly wasn't at the level of erudition that I have today. And it was because of, I think, my participation in the very first, token engineering sessions back in 2020, which was at the time, I think, the Balances simulations, supported workshops, that I really started to, to get my sea legs under me. And I want to, I'm very proud to now sort of be closing the loop and now coming back and offering that to the new cohort. And I hope to be doing it again into the future. And yeah, the course is structured to be, that kind of level of introduction in terms of assumed knowledge, but also, not, taking the training wheels off at the same time and letting it be exactly what it is without having to pull the punches, so to speak.
Yeah, and I think this is super relevant. We saw this in many of our training courses to, on one hand, I mean, our goal is always to make things accessible. And I think as token engineers, we have to be able to really read, understand, dig through these formulas. And there's no way to get around it. So no way as a token engineer to avoid going deep into the math of an algorithm design. But there's no reason to be afraid of it, right? And it'll be fun. And it'll be teamwork, and we'll have people from many different backgrounds. And that's why I'm very much looking forward to it. And ultimately, I think it's also a great chance to verify and question what's available out there. Since you said it's sometimes a mix of marketing and documentation, and I think anyone who's working on a protocol should be able to question and feel comfortable with formulating an algorithm and also verifying other white papers.
Yeah, and I think that this is something that I want to touch on in some level of detail, because there's, we'll be looking at 3 specific, like actually used parameterizations of concentrated liquidity. And we'll also be looking at 3 what I call natural parameterizations, which aren't actually used. And even though those, these natural versions, they look so elegant, and computationally they're actually very lightweight. And so it kind of begs the question, like, why isn't anyone using them? And that's an interesting question, because in some aspect, like, in some regard, like when you're thinking about developing a protocol and actually implementing it, there is a correct parameterization for your system. And there is kind of I want to say a misconception generally with sort of green developers, that when they're implementing concentrated liquidity, that there is like one way to do it. And when they're trying to make their system behave a certain way, that they have to add all of these kind of peripheral functions on top of, whatever the industry standard is. And that's a mistake. And that'll be one of the things that we're talking about, is that there's a reason why, that it's such a valuable skill to learn to describe the same mathematical object in many different ways. And usually one of those ways is the one that you should be using. And even if it's the one that no one's used before, doesn't matter, because your protocol might have a very specific use case, or a very specific action, or something, something that it does that isn't done by other protocols. And if that describes the system that you're creating, then you should become, I think, immediately suspicious, or at least, your curiosity should be roused that maybe if you're borrowing from somebody else's research, that you might be misappropriating, a function that was built for an entirely different use case, and actually there's a more elegant, more appropriate, more secure way to do exactly the same thing. And this is, one of the core learnings of the the series that I'll be doing.
Yeah, and here's one more super relevant aspect that we've highlighted in last week's Token Engineering Reads. This is our bi-weekly newsletter of TE Academy, and this was your article, Theory versus Reality, where you shared the design and implementation journey of Carbon DeFi. And I must say, this is a rare piece, first of all, because there's not much to read and publicly available insights on how a design process really looks like if you are not only doing research, but rather you are in charge to implement and roll out a protocol. And at some point, you have to be able to rate the implementation and test various approaches for implementation to manage and tackle the limitations blockchain system definitely has. And maybe you can share some examples where you, as a protocol designer, were in charge to guide also the developers for the implementation.
Yeah, and this is this is a really important point, because in a way, when I came into protocol design, I was very much the sort of pen and paper theorist, where you assume that because you can describe something, in pure algebraic abstraction, that someone is going to be able to figure out, how to make that work on a blockchain. And while that's, that might be true, the details of how it actually gets into the blockchain and how the blockchain uses that information is something that I think is, as you say, is very rarely spoken about, or the the design principles of getting an embedded system to behave well is something that you just don't find a lot of literature on. And so I was very happy to to write that article. But yeah, so let's go into a little bit of sort of the specifics there. And this is actually one of the I just gave my presentation at ETH Dubai on specifically this topic. And during that presentation, one of the analogies that I drew was that if you stack carbon atoms on top of each other, one after the other, and let that tower get so high that it's as tall as the Burj Khalifa, right? Which is appropriate because we're in Dubai. You get it. That's a certain number, right? So there'll be a number of carbon atoms that will be equal to the height of the Burj Khalifa, and it's an enormous, unfathomable number. And what's interesting is that the number of Shiba Inu Wei that's equal to 1 Bitcoin Wei is about 40 million times bigger than that number, right? And that so we're dealing with, and that's important because, you know, that's an exchange rate. You know, you need to be able to calculate very accurately what the rate is supposed to be. If someone's you know, quoting a price and you need to record that on the blockchain and then have someone execute against that price, that can be very challenging. Because you're either measuring something very small with something very large, or trying to measure something very large with something very small. And it really does push the bounds of computation precision, especially because, you know, Ethereum doesn't know what a number less than 1 is. You know, like in a fixed point infrastructure, you know, any number less than 1 rounds to 0. And that's going to be approximately half of all of the exchange rates that you're supporting. So it's like, oh, how do you deal with that? And how do you actually, you know, make sure that you're supporting a wide enough price range that your protocol is actually useful and not just, you know, appropriate for like a very, you know, select number of use cases. And that's really what that article is about. It's about saying that, okay, you know, eventually you're going to have to draw a line in the sand and say, what are the extremes? You know, can we find examples in the industry of tokens that are very, very difficult to deal with, and say, okay, let's assume that everyone wants to use these tokens. Is it possible to make the system behave well under those circumstances? And I think that this is where this is where science kind of bleeds over into engineering, because, you know, where science is about how you're going to do something or why you're doing something, the engineering is always about, okay, how do I achieve it? You know, how is this thing actually going to become reality? And that's the thing that I had to learn. This is the thing that I've been, you know, slowly developing my skills in over the last few years. And I'm very grateful to be working with such, you know, phenomenal software engineers at Bancor who've been, you know, able to explain these things to me. But there's a back and forth, you know, because it's my job essentially to maintain the big picture, and make sure that the actual underlying theory is being closely adhered to. And then it's the engineer's job to tell me what's what's possible and what's impossible, and then to come to some sort of a agreement between us about where the borders of precision really are. And so yeah, examples are things like, you know, if someone was to trade one way of Shiba Inu versus one way of some other token, you know, what are the rounding errors, and, you know, are you going to get exploited? And if we're doing functional composition, how do we make sure that that at each step of the process that we're not overflowing the 256-bit mandate of the Ethereum EVM, or do we need to do a large number implementation which allows you to do like 512 and things like that? But then, you know, all those things have gas costs. It's a really interesting problem because it kind of, even though computer systems are sort of abstract, it really does feel like actual engineering. Like, I now understand why software engineers call themselves software engineers, because it's resource management like anything else. Like, you can, of course, build an elevator to the moon, but, you know, it will cost, you know, hundreds of trillions of dollars or something. Or, you know, you can build an aircraft that flies at Mach 10, but, you know, it might kill the pilot and that kind of thing. And building smart contracts is exactly the same thing. You know, it's like, yeah, sure, you can create a smart contract that handles arbitrary precision up to, you know, 1 trillion decimal places, but it will, you know, exhaust the block limit every time. and people will be paying hundreds of thousands of dollars every time they try to trade. So you have to kind of work within the constraints of what the system can actually realistically support, and then find very creative ways to try and make all of these restrictions amount to more than the sum of their parts. And without going into the actual numeracy of what's described in that article, I think that does a good job of capturing the overall tone of it.
Yeah. And I must say, again, this is, you mentioned the term engineering, and that's why we also use this term engineering, because token engineering is not only about the economics of it, it's not only about the algorithm design in an abstract theoretical way. You have to find ways how to implement this, and this can be actually a tough nut to crack. And you have to also in the tradition of other engineering disciplines, since you're building public infrastructure, you want to understand where the system might break. You mentioned the rounding. It's so simple, but it's a tough nut to crack, how to then come up with a system that maintains precision in all potential exchange combinations, token combinations. And that's a pretty exciting challenge. It's a hard challenge, and it's something that I think needs way more education, needs way more people working on it, sharing this knowledge, and gaining experience, because this is actually a very young discipline, and we are just in the early days of it, handling billions of dollars in our systems. Okay, and I mean, what I also like very much for the concentrated liquidity from scratch live track at the study season is that we are collectively working on foundational knowledge on concentrated liquidity, and also contribute to the shared body of knowledge about this particular cryptoeconomic primitive. And I think it's another great example, and it has the potential to also be like a template to many other cryptoeconomic building blocks, where today we have implementations here and there. We are using the same word, like invariants, bonding curves, AMMs, pointing to totally different things. We see different implementations. We see a different formulation, and we'd like to bring more clarity and contribute to good resources. But there's even more, not only when it comes to white papers or the actual mathematical formulation of it. It's generally, think of other cryptoeconomic primitives. This can be staking in all its variants. It can be voting mechanisms in all its variants. And if we imagine this body of cryptoeconomic primitives in token land, in crypto land, we envision a library even of the primitives itself, their descriptions, their mathematical formulation, how the implementation and implementation solutions, also understanding the potential attack vectors and how to tackle them, including tools like you build a tool for your own team to building a model for your system, running simulations, maybe even dashboards for optimizing the parameters, and developing metrics to measure the success. So these are elements that we call the cryptoeconomic primitive suites for open source cryptoeconomic building blocks, with a shared knowledge, not only in form of a white paper, but in form of tools, mathematical specification, implementation details, maybe even smart contract versions. And this is, I think, something that the space really needs to further develop, and something that this as a perfect example of the public goods we need in the space, similar like open source software, open source cryptoeconomic primitives.
Yes.
And that's why I'm so glad you.
One of the there's.
Good. Go.
Sorry, we have a bit of a delay.
Yeah.
Yeah. What I think one of the things that you touched on there was about you know, like creating a body of knowledge, and the approach that I've taken to this program is to not just prepare, because I knew that I wanted to prepare, for example, syllabus style material, like proper reading material, as if the course had its own textbook. Like I'm writing the textbook for this course, and that's an important point. Like it's not, this isn't meant to be single use. While it has been prepared with the specific motivation for the Token Engineering Academy, course that I'll be teaching, the idea is that after that, it has a lot of reusability. Like this is meant to be, a source of future reference material that people can use when they are trying to, for example, prove one of their own parameterizations, or if they're, maybe someone's going to be working on a standard at some point that we can use to sort of categorize different types of concentrated liquidity expressions, this kind of thing. And so the idea is to be thorough enough that that everything that someone might need to refer to is included. And this serves two purposes. One is that if you are trying to, and this is why it's called from scratch, if you have the mathematical tools already and you're new to DeFi, you can read through this list and it will take you step by step through everything to be able to get you up to that level of expertise very quickly. But also that if you are, if you already have that level of expertise and you are writing a white paper or something for your protocol, you can actually save, maybe a lot of expository overhead by being able to refer to something that has already gone through the effort of, of proving certain identities or the relationships between certain variables and these kinds of things. So yeah, it's meant to, it is, it was designed to be a public good, not just because it's, it's for the lecture material and, for the students at Token Engineering Academy, but also for, future developers and things to be able to refer back to, so that everyone is at least referring to the same thing, rather than, this kind of, notation creep, where everyone starts to use different symbols and and different things. So yeah, I'm hoping that it will be adopted as like something of a standard way to communicate these concepts. And maybe that's a bit self-aggrandizing, and I don't mean it to be. I'm just I'm trying to express that the motivation here is to actually organize the industry a little bit, and to gather people around one way of communicating effectively. And obviously it's fine if you choose to use your own notation and that sort of thing, but at least you can still point back to something if you need sort of a Rosetta Stone to translate between different concepts very quickly. That's what this this paper is designed to do. And it will be on archive, so the lecture notes will be downloadable via archive prior to the course, and it will live there forever.
Yeah, that's the idea. Also for the study season, I mean, it's super important, I think, to have the opportunity to meet and collaborate in tracks like this, to go over certain principles and concepts together, to break it down, to understand it, to really gain a good understanding, and then at the same time create this shared body of knowledge via resources we make available together, not only for the study season itself, they'll be available after the study season as public goods. And we hope to make it useful for so many others who are working on similar concepts.
Yeah. And I'm really looking forward to putting together the exam material for the proof of knowledge at
Oh,
the end. I think
oh
that's
yeah.
going to be a lot of
Let
fun.
me say some words about the topic of exams and NFTs. So at yeah, you'll have the chance if you take part in Mark's sessions and go through the 4 sessions in the total program. You'll have the chance to take an exam, pass an exam, and then also prove your knowledge with an NFT that we mint for the students who pass this course. And these NFTs will be part of the token engineering token system, NFT system, to prove knowledge and achievements and contributions to the field of token engineering. We are doing this since 2022, since we've launched the T Fundamentals course for passing the modules. Also, speakers in more of the 100 events we have run so far have received NFTs. Attendees in our live events such as EFCC, and of course, speakers and authors of the learning materials at the study season and at other learning opportunities. And this way, we were able to create a system of NFTs to represent our own discipline. So it's a way for individual token engineers to prove their knowledge, and it's a way for us to monitor the evolution of our system and build new mechanisms on top, such as the reputation-based weighted voting mechanism, where we integrate a signal of expertise in our case, in token engineering, to the voting weight. So the more experience somebody can prove in the field of token engineering, the more weight they have in the decision of who should receive the fellowship prize. And this is again, a new primitive when it comes to voting that can complement one token, one vote, where the number of tokens held in a wallet defines the voting weight, that can complement delegation, where it's a matter of trust to delegate tokens to a decision maker. And reputation weighted voting is another one, where decision makers accumulate token weight via their achievements, via their track record, via their contribution to successful and impactful good decisions in the past. And I think this is a very exciting new component that can also help us to fix some of the problems in decision making that we currently have. Again, one token, one vote, also collusion when it comes to delegation. And it's definitely an exciting new mechanism. Yeah, and I hope we'll have the chance. Yeah, sorry. Go.
Sorry, didn't mean to interrupt you. It's we have a lag, and so please continue.
I just wanted to close. The goal of these learning sessions is, of course, to offer this in live sessions because we'd like to enable and facilitate the conversation in our community. Plus, on top of it, publish the materials created during the study season for anybody else to learn from it in the future and to benefit from the resources created.
Yeah, and I think that you touched on a concept there that I think is super important and is actually very meaningful, even unique to Token Engineering Academy, which is kind of this idea of credentials, meaning that these proof of knowledge NFTs, they're not handed out as like as participation awards. This is it's meant to be a something that is symbolic of an active engagement in and the garnering of skills that one didn't have before and that are appropriate or meet some minimum standard as as the instructor intended. And unfortunately, this is we in the world of cryptocurrency, we often talk about things like the financial world letting everyone down, but also the university system is letting everyone down. And there's a very much a drift towards if people can afford it, you can basically buy any degree that you want, even from top tier universities. And there's been a lot of leaks and exposés and things over the years, but it doesn't seem to have done anything to slow it down. And I do really appreciate that the TE Academy system does have this exam component, and that it takes it seriously, that it's not a feel good sort of it's not about entitlement. It's about proving your mettle if you've actually met the criteria of the course. And it's unfortunately, this is becoming a rare attribute. That I hold the TE Academy proof of knowledge receipts in very high esteem. And I will, I want to make sure that I honor that, that philosophy when I come to creating my proof of knowledge exams.
Yeah. And I must say, of course, for us, it's also an endeavor to make these certificates hard to game, also find new ways. I mean, we haven't tried other on-chain forms of attestations, mutual attestations. There are so many exciting forms. But what has already paid off is that we build a very robust system where it takes a while and it's challenging to acquire these NFTs. But then once you have it, we can really build robust systems on top where we can maintain this trust in the system. And I think we'll prove it again with the fellowship decision, where we had this weekend selected the candidates from all the applications. But ultimately, the community will vote on who should get the fellowship grant. And I'm pretty excited for this voting, because it will be both. It will be a vote for an individual sharing their knowledge. And it will be a vote for what is most relevant and well received in the community as important learning material, as an important aspect of token engineering. And that's why, for us, it's very good, logical, and healthy next step to further develop our NFT system.
Yeah, and I think I speak for Angela and I both when I say that I'm completely blown away by the candidates that were selected are of an extremely high caliber, and the things that they are proposing to teach are in some cases completely bleeding edge, and they have such a demonstrated command over their respective disciplines, and these are things that they've been able to substantiate with either a very consistent sort of publication record, even if it's just on Medium or something like that. But the candidates are all phenomenally good, and I'm really looking forward to seeing what which one of these courses the community thinks was delivered the best and is the most relevant to token engineering. I think it's going to be a tough decision, but that's kind of why I'm so curious to see what the outcome is.
Yeah, absolutely. And you see me smile because we didn't even announce the fellowship candidates. If you are watching as an applicant, you'll receive the information today, we promise. And stay tuned and follow our Twitter, Talk Engineering, to find out what the fellowship candidates are and what they offer as learning sessions. And as you mentioned, it's the first round. It's our first experiment in the fellowship. And I think we can definitely say this is content you find nowhere else. And it's something unique, and don't miss the chance to follow the live tracks at the study season. Register today, tokenengineering.net. Okay. Yeah, Mark, really enjoyed it. Thanks so much for the session.
Yeah, my pleasure. I'm going to apologize on Jen's behalf. She's plugged into the hotel intranet, and so it booted her off the network, I think, for data consumption. But she's been beside me the whole time, and she's been listening to everything that we're saying, so she's up to date. But yeah, deepest apologies that she had to drop from the stream. And thank you so much for doing the call with us.
Yeah, And we'll meet next week. Looking forward to the study sessions. Concentrated liquidity from scratch with Mark Richardson. Thank you. See you next week, everyone.
Thank you. Ciao.
Ciao.